Hey everybody, my name is Dan Friedman. I'm a data center solutions architect at Cisco, and today I wanted to spend time talking to you about Cisco AI PODs. Now, the way I'm going to do this presentation is maybe a little bit backwards from how I usually do it. This slide is intended to summarize key points of the presentation while also providing a means of navigating to the other slides in the deck after the fact. Okay, so you could say that this slide provides a summary of all the key takeaways from the presentation, but I'm giving you those takeaways up front so that later you can return to the presentation and use this slide as a table of contents reference to quickly recall key points and also find the information that you're looking for. So basically, the presentation is going to follow the flow of the bullet points that you see on this slide underneath Cisco AI Pods. We're going to dive into the details of each of these points on the following slides, and I'll give you a quick minute to read the text in green. How those comments in green relate to the summary points on the left is primarily what we're going to cover in the rest of the presentation. So, there's key AI adoption issues that include infrastructure modernization, AI safety and security, skills gaps, performance, etc. We'll talk through those in a bit more detail. But this kind of gives a high level introduction to some of the key concerns that we're trying to address when deploying Cisco AI Pods for customers. And in the top right portion of this slide, you'll see that the main point can be summarized in a couple of words, right? Simplify AI deployment and time to market for enterprise customers. Now, there's a lot more to it than just that. Like I mentioned, there's performance, there's skills required, and we're trying to address all of these concerns basically at the same time. The points under Cisco AI Pods cover the essential messaging needed to communicate the value and capabilities of Cisco AI Pods to your customers, obviously emphasizing simplification, scalability, flexibility, and our unique integrated approach to AI infrastructure. Okay, so we said on the summary slide that AI pods simplify and accelerate AI lifecycle deployment. So let's dig into that comment a little bit. And you'll notice that at the top of this slide, the heading is Simplify and Accelerate AI Lifecycle Deployment. So as I was saying on the previous slide, right, you can use that as a table of contents. Topics are going to be covered in order. All you need to do is look at the heading at the top to kind of understand what the content of the slide is intending to talk about. So first, what does an AI pod consist of? And the answer to that question is it consists of a lot of things, and all of those things are shown on this slide. Obviously, there's a lot going on here. So without getting into the weeds by naming or describing each individual component, what are the key things that I want you to take away from this slide? First, visually, you should be able to see that AI pods consist of many hardware and software pieces, which taken together form a full stack solution of integrated components, right? That's key takeaway one. Two, I want to draw your attention to the yellow text at the top. Choice means flexibility for the partner and customer. The question is how. So if we look at each of the places on the slide where I've put a yellow choice, for example, if we start in the middle, right, we've got flexibility and choice when it comes to the selection of desired storage vendor or platform. We've got choice of different orchestration layers, including Red Hat OpenShift or Rancher. We've got choice of AI software, including NVIDIA or open source. Granted, open source is not shown here because open source means you as a customer would technically be supporting your own, supporting yourself when it comes to the AI software. And so we only show NVIDIA software here because that is what Cisco will provide support for. On the right, you can see that you've got choice of services, either partner or Cisco led, or in cases where maybe you're dealing with a customer that already has a lot of AI skills, maybe they provide the services for themselves. And then on the left, you've got choice of different security components, including things like AI defense and Hypershield and Smart Switch. You've got choice of workload management and operations tools. And um, yeah, so basically a lot of choice. And all of these different choices are still part of the overall AI pods architecture, right? So all of these choices, regardless of what you choose, um, is still going to be supported by Cisco. So ultimately, this allows you, the partner, to customize the solution for the customer based on their preferences and their skill set capabilities, right? So if they're already familiar with, let's say, Nutanix, maybe that's what you want to leverage from a storage platform ecosystem perspective. If they're already familiar with Red Hat OpenShift, maybe that's what you want to use for your Kubernetes environment. If from an AI software perspective, if they want support, they'll want to go from Cisco, they'll want to go with NVIDIA. But, if they're looking to save on costs and they have confidence in their skills and abilities, then they can, of course, go with open source AI software, right? So, third, now I want to draw your attention to the orange text and boxes on the left. And so, what would I want you to take away from that? First, AI pods form the base building block of Cisco's secure AI factory. So when you layer in the security products shown inside the orange box, such as AI Defense, Hypershield, etc., this is what will create what we are calling a secure AI factory. These integrations are built into the solution. They're not bolt-on and they're not a partnership, right? These are Cisco native technologies. So this is one of the areas where our competitors just can't compete. Arista and Dell don't have integrated security offerings to embed security into the architecture of their equivalent of AI pods. They may be able to bolt on security via partnerships, but often partnerships like that create management headaches and finger pointing when things go wrong. So with Cisco's Secure AI Factory, all components are Cisco native. They're built into the architecture with one throat to choke when it comes to support. Basically, the customer calls Cisco, period. Second, AI pods are based on a pre-validated architecture. So Cisco CVD, or Cisco Validated Design, means that lots of integration and performance testing has gone into the solution to ensure compatibility and a smooth customer deployment and end user experience. And AI pods comply with NVIDIA's ERA, which stands for Enterprise Reference Architecture. And basically, that just means that NVIDIA stands behind the solution in terms of design and performance. Now, we've already kind of covered a lot just on this one slide. So to reiterate the key points before we move on, one, AI pods consist of many parts which together form a full stack solution. Two, AI pods allows for a lot of flexibility of choice for both partners and customers. Three, AI pods form the basic building block of Cisco's Secure AI Factory. And four, AI pods are CVD backed, which saves customers time and money while guaranteeing compatibility and performance. Okay, so we also provide flexibility in operating models with respect to network management, which wasn't really covered on the last slide. So if your customer prefers an on-prem managed solution, then they can leverage Nexus Dashboard with Nexus operating system running atop Nexus 9K hardware. And this means that the customer would be responsible for configuring the underlay network, which is a manual process, right? So that can be laborious. It depends on the type of network that you're deploying, but let's say you're deploying VXLAN, EVPN. There's a lot of configuration details that need to be planned out and properly configured in advance to result in a properly operating fabric. Now, if your customer prefers a cloud managed solution, then they can leverage Nexus Hyperfabric, uh, which which uses Sonic operating system on Nexus 6K hardware. And the additional benefit, right, is that Cisco is responsible for configuring of the underlay, and that is a fully automated process. So this is not only is this a cloud managed solution, which might be a preference of the customer, but it's also a more turnkey solution in terms of deployment because the underlay configuration is Cisco's responsibility and happens in an automated fashion. Okay. So on to the next point from our summary slide. We said that AI pods address enterprise AI challenges. So what are those challenges? And on this slide, I've listed in bullet points some key AI adoption issues. These were brought from the summary slide up front, and these are typical issues for most enterprise customers. These points are supplemented and reinforced by the image at the bottom of the slide. So to summarize, IT is complicated enough without making it worse. Customers are concerned with complexity, and that complexity has a lot to do with compatibility of the multiple different components that comprise the solution taken as a whole. Customers are concerned with security, they're concerned with performance, and they're concerned with their ability to deliver business value based on the presence or lack of required skills. Also, GPUs demand a lot of power and generate a lot of heat, and that makes power efficiency and adequate cooling in the data center an absolute must, right? you can get in you can get into the realm of liquid cooling discussions here, which is very much a hot topic but not widely adopted at this point in time. The reason it's not widely adopted is because this is very much a data center or facilities readiness conversation. It's not like today's data centers or co-locations have liquid cooling mechanisms at the ready built into their existing infrastructure. So this requires data center providers to largely overhaul how they deliver adequate cooling in their facilities. And this is the reason why liquid cooling is being investigated by many, but not widely adopted today, at least not yet, right? So data center providers are likely to invest in building new facilities rather than overhaul existing facilities. But building new facilities takes time and is expensive, right? It's an investment. And until there's a requirement for liquid cooling, which I think we're getting towards, right? We have very high wattage GPUs now going into our servers. But until it's an absolute requirement, there's no other way around things. There's no way to continue cooling the data center just using airflow. Then liquid cooling will be slow to be adopted, is my opinion. So ultimately, customers they just want to build their AI applications that are specific to their business needs, and that alone is a challenge in its own right, right? And it's where the true value for the business lies. And then they just want to bring those applications online without a lot of additional headaches. So as we've already discussed, AI Pods enables this, right? Cisco AI Pods are pre-validated full stack infrastructure solutions designed to simplify and accelerate the entire AI lifecycle from data preparation to training to fine tuning to inference, which covers a whole spectrum of use cases, right? Um, AI pods integrate compute, high performance networking, and storage with unified management and software stacks, providing an enterprise ready platform that reduces complexity and speeds the business innovation, right? Speeds their ability to bring these AI applications online. And what that does for customers is it reduces stress and it ensures that there's a good end user experience from an application perspective. It reduces time to market by allowing customers to focus on building and easily deploying their business specific AI applications that provide value back to the business. Okay, so in a nutshell, customers just don't want to have to address each of these concerns on their own. Instead, they're looking for vendors like Cisco to solve these problems for them so that they can focus their attention where it belongs, which is where it brings value for their business. Okay, and this is the entire intent behind AI pods. Okay, so we said on the summary slide that AI pods expand use cases and capabilities. So what do we mean here? And in order to explain that, I need to add a bit of context. So to preface this somewhat, this discussion assumes that you come today already knowing what training, optimization, and inference refer to from an AI perspective. And we also assume that you know something about UCS in general, or in particular for this discussion, X series. So from that perspective, I'm not going to do a super deep dive on these topics, but I'll try to briefly summarize for those who don't have this understanding. So hopefully you can follow along with the presentation. Okay, so what is the context? Basically, AI pods were released in two phases as of today, right? We've had a phase 1 and a phase 2. So naturally, I'm going to start by talking about phase 1 or version 1.0, shown in the orange box in the upper right corner. Then we'll move on to phase 2, which is basically everything else that you see on this slide. Okay, so try to focus your attention for the moment on the orange box in the upper right. About a year ago, what Cisco had to offer customers was basically encapsulated inside of that box, and it consisted of UCS X series. This is what we had ready to sell, right? So specifically the X9508 chassis and the blade servers that populate into that chassis that we had at the time. And what this enabled customers to do was to basically get started with GPUs, right? With AI. Basically dip their toes into AI, leveraging existing or maybe new investments in X series. And while that's true, X series blades have physical size and space constraints which limit how much GPU you can cram into a single chassis. So we're going to have a look at that on the next couple of slides. But first, what I want you to notice is that 1.0 was focused on inference only use cases. So I'm using my mouse here to show inference on the slides. There are other cases that have to do with optimization and training, which we're going to get to in a moment. But in short, right, inference means you didn't need to train or fine tune your own model. You didn't necessarily even have to give the model access to some external knowledge base specific to the domain of work that your company focuses on. You were basically able to download a pre-trained model, leverage the knowledge that it had intrinsically within the model itself, and use that to address relatively basic AI use cases such as text summarization or text translation, etc. Right? And these are use cases that don't require a ton of GPU horsepower, and therefore, these types of inferencing use cases we feel are widely applicable, meaning pretty much every customer on the planet, regardless of their industry, regardless of their vertical or focus, every customer can take advantage of these types of use cases, right? They're widely applicable. Okay, so how did we deliver that inside of X Series? So here we're showing a picture of a chassis in the upper right corner with blade servers and X440P PCIe nodes, which we can also just call GPU nodes. So if you look at slot 1, which I'm showing here with my mouse, hopefully you can see me pointing that out, slot 1 over here, you will see a compute node, i.e. a server. And if you look in slot 2 right next door, this is the one that's highlighted with the red outline, then you will see a GPU node, i.e. the X440P PCIe node. So what we want to do here is assign the GPUs that are on the X440P node in slot 2 to the compute node or server that's in slot 1. So the question is, how do we do that? And the answer is we use the XFabric module or the XFM, which we're going to cover on the next slide. So this slide also talks about what GPU configurations are supported on the X440P, but I'm not really going to cover that, so I'll just leave that information here for your reference, okay? And one thing to note is that the X440P is a single wide node, right? Meaning it just occupies a single slot in the chassis. Okay, so here, and I'm pointing to these green arrows on the bottom of the rear of the chassis. This is the X Fabric module. It's mounted, as I said, in the bottom rear of the chassis, and its purpose is to allow east-west traffic between the GPU node and the compute node that we saw in the front of the chassis. So one thing to notice here is that the XFMs, this is version 1.0, so I'm going to point that out up here, the 9416 XFM version 1.0. So this has been out for a while now. These XFMs have no external ports. So if we're just looking at the image here, you can just see it's kind of got this wire mesh, but there's a couple of arms that help you eject or insert the module into its slot, but there's no like ports on this module, right? And so what that means is that the XFM handles intra-chassis traffic only, meaning within the chassis, right? There's no external connectivity. There's external connectivity up here with the IFMs, so let's talk about that real quick, right? But there's no external connectivity from an XFM perspective. So all of the east-west traffic between compute node and GPU node has to happen within a single chassis, okay? Now, at the top, we see the IFMs. These are at the top rear of the chassis. IFM stands for Intelligent Fabric Modules, and their purpose is to allow north-south traffic between the servers in the chassis and the northbound fabric interconnects and northbound network. Okay, so this is essentially how all of your customers are going to access the GPU-enabled business applications that are running on the servers installed inside this chassis. So these two slides basically summarize the hardware that was available at the time that AI pods were first brought to market, i.e. version 1.0. Okay? Okay, so the original AI pods that I've been talking about focused on inferencing use cases, as I mentioned. That was that orange box back on that first slide, right? The expanded versions of AI pods now support very large RAG, fine-tuning, and model training use cases, which is to say the expanded version of AI pods, which we haven't really dived into yet, they enable a broader set of AI workloads to run on the hardware. So we're going to get to that in a moment. But first, I want to finish off AI Pods version 1.0. So there's multiple flavors of AI Pods version 1.0, but they're all intended basically for inferencing use cases and they're shown here on this slide. These use cases include AI Edge Inferencing Pod, AI RAG Augmented Inferencing Pod, AI scale-up and scale-out inferencing pods, and newer AI pod major line bundles with enhanced hardware and software capabilities. And so up at the top, you'll notice that I've provided in the orange box SKUs that we offered in version 1.0 of AI pods intended for these inferencing and RAG use cases. If you don't know what RAG is, basically it's the ability to take an open source pre-trained model which has general knowledge of its own, but it doesn't have knowledge that's specific to your business, right? And then RAG is what allows you to tie that general knowledge model to an external knowledge base that provides information that is specific to your business. So in this way, you can enable the model to tap into knowledge that isn't natively built into the model itself. And then it can use that knowledge when formulating responses to users of the AI business application. So the main things that I want you to notice on this slide, I already mentioned to you the SKUs up at the top. You're also going to notice the different types and quantities of GPUs aligned to each SKU or use case in the middle, right? And there's also images of the chassis and the number of compute and GPU nodes installed for each SKU. so you can kind of get a sense of, what's low end or has little amount of hardware versus relatively high end where the chassis is fully populated. There's also different quantities of certain, like I'm mentioning, right, different quantities of servers, but there's also different quantities of CPU and RAM, right, and drives. But the main thing here is AI business applications scale based on the GPUs that are supported in the box. Okay, that's the main thing I want you to notice. Okay, so now, right, we're going back to that original slide where I said just focus on the orange box in the upper right corner, version 1.0. And I also said, version 2.0 focuses on a broader set of use cases, including optimization and training, which was showed on that slide. So how do we do that, and how have things evolved since AI PODS version 1.0 was announced? In December, we will have the X580P, which is the next generation version of the GPU node to the 480p. And we're also going to have the XFM 2.0, which is the next generation version of the XFM from version 1.0. So what are the key differences? The X440P and XFM 1.0 were based on underlying PCIe Generation 4 technology. Conversely, the X580P and XFM 2.0 are based on PCIe Generation 5, which means they're faster, right? So that's one primary difference between the older hardware and the newer hardware. It's just faster, and that's probably not much of a surprise. In addition, I pointed out that the X440P was a single wide node. In this diagram, and I'm using my mouse to kind of show where I'm talking about, you'll notice that the X580P is now a double wide node, and that just means that it can accommodate newer, larger, faster GPUs, okay, essentially. Finally, I had pointed out when I was talking about XFM version 1.0 that it basically just looked like wire mesh in the back. It had no external ports, and therefore it just handled intra-chassis east-west traffic between compute and GPU nodes. However, XFM 2.0 does have external ports, which means it can connect to an isolated backend network for AI workloads that demand more GPU that can be provisioned within a single chassis. So that means X series with the new hardware can now support AI applications that require a multi-chassis GPU solution from a horsepower perspective, right, in order to power their AI applications. Okay, so here I'm showing a picture of the XFM 2.0 modules with two SuperNIC slots apiece. So I'm pointing at the diagram here where my mouse is. We've got XFM1 in slot 1 and XFM2 in slot 2. So we've got redundancy there built in. And as these are mounted horizontally across the back of the chassis and the blade servers are mounted vertically across the front of the chassis, each server connects to both of these XFMs. So if we lose one, we still are in business. And then each XFM can have one or two SuperNICs, and each SuperNIC will have one or two ports. So you can put in a one port 400 gig SuperNIC into each SuperNIC location. So one here and one here, or you can install a two port 200 gig SuperNIC, one here and one here, depending on what your back-end network equipment looks like. And so, obviously this diagram is depicting 2 by 200 gig SuperNICs connecting to an external back-end 200 gig network. And remember that this back-end network is a network that supports GPU to GPU communications across different chassis in support of a single AI business application, right? So that multi-chassis GPU solution that I mentioned earlier. Okay, so we got a little bit into the weeds there, But basically, I was just trying to provide you a quick summary of where we started with X Series and try to show you how X Series itself has already grown in capabilities just in the last year. So now I really want to move on to AI Pods version 2.0. I kind of did that a little bit there with the newer hardware. But I'm getting back to the original slide that I showed you to point out something that I think is far more important. It is important that customers with existing X series investments can extend those environments to support multi-chassis GPU if that's what they want. But we're also providing a lot more horsepower and additional options, right? So moving on to AI Pods 2.0, this basically expands AI pod capabilities beyond what we could do with X series in AI Pods version 1.0, which remember, and is shown here in the slide, was really focused on inference use cases only. And the way that we're doing that is by adding support for C series servers. So now we're getting into some pretty serious performance territory, right? Specifically in this slide, I'm talking about the C885A, the C845A, and the C880A. Okay. So those boxes are more intended. It's not that they can't run inference. Of course they can. Uh, I'll mention about that here in a minute, but they're really more intended for training and optimization type use cases shown within the red box. Okay, that's kind of their sweet spot, if you will. So the C885 is a fixed 8 GPU box, which means the minimum and maximum number of GPUs in this box is 8. There is no flexibility. You get eight GPUs, period. Also, if a single GPU dies, you have to replace the entire GPU tray, which results in basically an outage to the entire chassis, right? If you don't have redundant infrastructure to keep things going. So the GPUs that are supported in that box are top-end performance GPUs meant primarily for training use cases. We're talking about the H100 and the H200 GPUs here, right? Everyone's familiar with that. So this box is capable of helping customers build their own models via training, but realistically, this is offered, I would say, more for completeness of our compute portfolio because only large hyperscaler type companies like Meta and Google and others are building their own models. So if a customer wants or needs to train their own models, then we can certainly support that using this box. Okay. Next up, we've got the C845A, and this is a modular, not fixed, 2 to 8 GPU box. So the minimum number of GPUs is 2, the maximum number of GPUs is 8, and you have the flexibility to deploy 2, 4, 6, or 8 GPUs in this box. So in short, what this offers customers is more flexibility, and also the GPUs are more serviceable or field replaceable than I described for the C885A box, where you have to basically, down the entire chassis. So we expect to sell far more of this box because its flexible configuration allows it to address a much wider range of use cases, plus it's just more serviceable. So those use cases span all the way from training to fine tuning or large inference, such as in AI applications with high levels of concurrent users or frequent requests per second or both, right? The GPUs in this box are similar to the ones in the C885. They are still H100 and H200, but the ones in this box are variants of the H100 and H200 in the C885 that are slightly cheaper and slightly less performant. However, they're still very capable of running training workloads, right? So again, this box is really focused on modularity and flexibility for a wider range of customer use cases, and we expect this to be more popular than the C885, right? More sales here. So both of those boxes, the C885 and the C845, have AMD CPUs and support the H100 and H200 GPUs, as I already mentioned. They also both support AMD GPUs. So when I say H100 and H200, those are NVIDIA GPUs, but these boxes both support AMG, AMD GPUs, which are cheaper, performant, and gaining in popularity, as is reflected by AMD's stock price as of late. Finally, the C885A is a modular Intel-based box, which supports B300 GPUs with a bigger memory pool and can therefore support much larger models. So it's just another addition to the portfolio that helps us address, specific use cases. So, in summary, today's Cisco compute portfolio is complete in that it can support the full range of AI use cases. That was untrue when we first started with AI pods in version 1.0. But now that we're in version 2.0, we've got a much more complete portfolio and the ability to support all kinds of AI business application use cases. With the C series added to the AI pods architecture, we can leverage AI pods for the full gamut, all the way from training, which requires heavy GPU resources, to RAG and fine tuning, which are considered optimization. Shown here on the slide, those typically require a moderate amount of GPU resources, all the way to inferencing on the right, which can require anywhere from low GPU resource for simple AI use cases like text summarization and translation that I mentioned earlier, to high GPU resources for AI applications that have high concurrent users, requests per second, or both. And as the slide says, this provides one solution, one architecture for your AI journey. You basically size the solution to address the customer use case by leveraging any of these pre-validated components. All right, moving on. So on the summary slide, we're going back to that, right? We said that AI pods provide scalable and modular infrastructure. So here, I'm going to introduce the concept of a scale unit. And all this really means is that you as the partner can size the solution based on today's customer needs without you or the customer having to fear that you'll have to start over or re-architect a solution from scratch when the customer needs to grow their environment in the future. So scale units provide a means for you to easily scale out the environment as customer requirements evolve and change. So whereas today they might be stepping into AI by fine-tuning an existing model for a single AI business application, when they achieve success with that, they're inevitably going to be like, hey, we want more, right? We want to build additional AI business applications that address additional use cases that provide value back to our business. And that's when they're going to require more hardware resources. So, put simply, scale units are how Cisco meets customers where they are today without restricting their future growth. So this slide shows an example of our scale unit types. And if you look at type 1 on the left, this shows 2 leaf switches and 4 C885A servers, each with 8 GPUs for a total of 32 GPUs, right? And we could use the C845 with a lesser amount of GPUs and the flexibility, or we could use the C880, but we're just taking an example here, right? So that's type 1, right? Basically maxes out at 32 GPUs. Now, if you look at type 2 in the middle, you'll see that to get to 64 GPUs, okay, so here's 32 GPUs, here's 64 GPUs. In order to get to the 64 GPUs, you need a slightly larger leaf switch that offers more ports. So here in type 1, we were using the 9332, which is a 32 port switch. And here we're using a 9364, which is a 64 port switch. And the reason for that, right, is because we're doubling the number of C885A boxes. And each one of those boxes requires, as it shows here, 8 by 400 gig per node. So there's a lot of connectivity going on between each one of these C885 servers and the upstream network devices, right? Which is why we need to increase the number of ports when we increase the number of boxes to deliver an increased number of GPUs. Okay, so the amount of GPUs is now larger at 64 GPUs for Type 2. And so you can now tackle AI business application use cases that demand more GPUs. So, or it may not even be a singular use case demanding additional GPUs. It could be that you just want to run additional use cases in the same environment, right? So maybe your first AI application requires 32 GPUs, and your second AI application also requires 32 GPUs. You can now run both of those applications on scale unit type 2 with a total of 64 GPUs. Now, if you look at type 3 on the far right, you'll see that to go to 128 GPUs, you again double the number of C885 A boxes. And yes, this example shows a different model leaf switch again. So what I'll say here is that these are just examples, right? I don't know the details, all of the details of why these specific leaf models were chosen to be put in these slides. And I don't believe that you will be replacing leaf switches when you need to add more compute nodes. Okay, this is more about positioning a leaf switch up front that will allow the customer to scale to the predicted need for resources in the future. So as an example, if you think that you're going to grow to 128 GPUs in the next couple of years, then you're probably going to want to get this guy, the 9364E SG2 switch, shown, right? Because we know that that can accommodate scale unit type 3, which will get us to 128 GPUs. So again, we're just trying to offer flexibility and ease of scale out to customers here. So, work with your Cisco account teams to position the proper switches up front based on anticipated growth in GPU needs over the next, X coming number of years. So Cisco AI pods offer these modular scale units for predictable and scalable growth. They support a range of hardware, including X series and C series servers. Again, we're just showing C series servers in this slide just for example purposes, with both Intel and AMD processors and expanded GPU support, such as NVIDIA H200, the AMD MI300X, and more recently, the B300. And then the networking part is powered by Nexus 9000 series switches with options for high port density and smart switching. Okay, so back to the original slide again, right? AI pods come with unified cluster management via Cisco Intersight and Nexus Dashboard. So this is kind of the next point on the summary slide at the beginning of the presentation about, AI pods provides unified management and cloud managed options. So the unified management aspects are referring to Cisco Intersight and Nexus Dashboard. Why? Because with Intersight, you can manage an infinite number of UCS domains regardless of their location, right? Intersight is a SaaS-based offering. It runs in the cloud. Cisco's responsible for scaling it. Technically, it runs inside of AWS. And so you don't need to worry about the resources that are supporting your instance of Intersight, because as you add additional UCS domains, we will automatically scale the backend resources supporting Intersight to accommodate the additional domains that you want to support. All right, it's all handled for you. And I guess I should say similarly with Nexus Dashboard, you can also manage an infinite number of network fabrics regardless of their location or type. I shouldn't say infinite here, right? Because it is resource based, and when you're on-prem, you have a finite amount of resources that you're working with. technically that's also true in cloud. It just doesn't look that way. So, just take that, I guess, take that comment with a grain of salt. But the idea with both Intersight and Nexus Dashboard is the ability to manage either compute regardless of location or network fabrics regardless of their location or type. Okay. Now, from a cloud managed options perspective, I already mentioned Intersight is a SaaS offering fully maintained by Cisco, which means customers don't have to manage their management platform, right? Your management platform becomes another point in your infrastructure that you need to, upgrade and test. And when it's not available, you can't make changes to your environment, etc. So with Intersight, new features are rolled into Intersight on a regular basis via CI/CD, and that means that there are no maintenance windows for customers to benefit from new features coming into Intersight. All they have to do is log out and log back in to benefit from new features. And of course, the features you see are tied to your Intersight licensing level. Now, um, we talked about unified management with Nexus Dashboard, but that's on-prem and controls NXOS-based fabrics, right? So if you want a cloud-managed network fabric, then you've got Hyperfabric. And just like Intersight, this is a SaaS offering that's fully maintained by Cisco, so you don't have to manage your management platform. Plus, as we previously covered, you also don't have to configure the NXOS underlay. So Hyperfabric provides a more turnkey deployment option. So our cloud managed tools enable the easiest deployment, monitoring, and lifecycle management of all your AI infrastructure. Okay, so we're getting towards the tail end of the presentation here. We said that on the summary slide that AI Pods provides differentiators versus competitors. So I don't really have a visual slide to talk to these points, so I've just included the key points themselves here on the slide. I'll give you a quick minute. I'll pause and give you a quick minute to read through those real fast. So to summarize, primarily, I would just highlight that many providers like Arista and Dell, they have no answer for security concerns. And similarly, security providers like Palo Alto, they have no answer for compute or GPU concerns. Now, there may be partnerships between these organizations, but basically what that results in is bolt-on solutions with support challenges and finger pointing for customers, right? Only Cisco brings to bear the full set of integrated and validated infrastructure needed to address the full spectrum of AI application use cases while addressing security and performance needs, while providing flexibility of hardware and software components, while providing flexibility of network management platforms, while providing a single throat to choke from a support experience perspective, etc. Okay. And finally, we said on the summary slide that AI Pods includes partner enablement and support. And so, similar to the last slide, I don't have a visual slide to talk to these points. So, I've just included the key points themselves. Up at the top, Cisco provides partner programs, validated designs, and comprehensive documentation to support partners in selling and deploying AI pods. Partners can leverage Cisco's expertise to help customers right-size their AI infrastructure investments and balance current and future business needs. Okay, so that's kind of what we were talking about with our scale units. So I've also included on this slide a list of resources that are available to you. I'll kind of quickly read through them. We've got the Cisco AI Pods partner FAQ. All of these bullet points here shown in blue are clickable links. Okay. We've got the Cisco AI Pods landing page, at a glance, solution overview, and inferencing data sheets available. We also have a link to Cisco and RAFE partnership. This is a white paper, and basically RAFE is a company that allows AI pods to behave as a self-service GPU cloud. So similar to the type of experience that you would get from a cloud provider, but using on-prem equipment. Sales Connect is always a great resource. If you click that link, then you would want to search AI pods underneath sales collateral, and it'll pull up all the latest and greatest for you. Products and solutions is another link that I've discovered recently. That's a really nice one, I think, to bookmark because it doesn't just cover AI pods, it covers all different products inside of the CAI or data center architecture. And you can literally just click on a product name and it'll take you to the latest set of resources, that discuss that product. So I think that's definitely a one that's worth bookmarking. Cisco provides funded instructor-led training quarterly. I typically send out information about these training opportunities in my mailing list. So if you'd like to get on my mailing list, then please reach out and let me know. That's not a problem. We also offer to partners the ability to have a dedicated course just for you. And because a lot of these instructor-led training courses are one to many, meaning one training partner teaching many partners. But we can do one-to-one dedicated courses if that's of interest to your organization. We've also got Cisco Voice of the Engineer and Partner Success webinars. I also send information about these upcoming sessions via my mailing list. So again, if you want to get on my mailing list, just let me know. I send those out as they become available. And for the Partner Success webinars, if you visit that link, there's a Register Now link shown on the right side of the page that will allow you to basically, see the upcoming schedule of webinars and participate and register for those individually as you're interested in the topics that are coming. Okay, dCloud provides always available walkthrough labs and demonstrations. Black Belt Academy provides always available training, and completing these stages or courses contributes to the company that you work for, their partner certifications with Cisco. So it's a nice way to sort of help benefit your company. And then, we also have the CAI Partner VT, which is a virtual event that we hold approximately once every 6 to 9 months to cover pretty much everything CAI or data center product related. And it's a partner facing event. So we've got lots of enablement support. I'm sure the list doesn't end here, but this is a great list of resources that you can leverage to get started. Okay, and then finally, you may have already seen a slide like this before, but I just wanted to provide the slide to get your mind turning about common or popular use cases. Don't know why the slide auto advanced there, that apply across industries, verticals, and customers. So all of these use cases can be deployed atop an appropriately sized AI pod. So with that, I hope this presentation helped you understand what Cisco is aiming to achieve for customers with AI pods and how we're aiming to achieve it, providing flexibility and scale out capabilities, etc. If you have any questions, feel free to reach out to me. Thank you for taking the time to watch this presentation. Cheers.